Good morning, students. It's 20th of April, and today we are going to learn about molecules. I want you all to open your books, page number 493. Molecules. When you snap two bricks together to make something, many parts act as one part. The same thing happens for atoms when they form molecules. Molecules are particles with more than one atom joined together. What are molecules? Molecules are particles with two or more atoms joined together. When two or more atoms are joined together, a molecule is formed. When two or more atoms join together, a molecule is formed. Most of the atoms in the world exist as part of a molecule, not on their own. Means most of the things found in the world, they exist in molecular form. They exist as a molecule. Objects in the world are just molecules grouped together. Whatever the objects in the world, they are just molecules. They are just atoms joined together. All the things, they are made from the atoms, and the atoms are in the molecular form. So we say that all the things in the world, they are just molecules that group together, and we form so many different types of things. We found so many different types of materials. When a molecule forms from elements, atoms link together through their electrons. Now, when molecules are formed, how they are linked with each other? They are linked with each other because of the electrons. Electrons are linked together. They share the electrons. That's why they are linked together. This causes molecules to have different properties from the elements. Now, what happens when the electrons are shared? Molecules are formed. Now these molecules have different properties than their own elements. When the molecule is formed, they have its own properties other than its elements. With about 112 elements, the different kinds of molecules that can be made is nearly infinite. Now we have nearly 112 elements. With these 112 elements, how many types of molecules can be formed? They are infinite. There are many types of molecules can be formed. By forming molecules, atoms combine to form different materials and provide all the variety around you. Now what happens? They make molecules with these 112 elements. Molecules are formed, and with these molecules, we get different types of varieties around us. Scientists describe molecules by combining letters and numbers into a chemical formula. Now, there are many types of molecules. There are many molecules. So the scientists, they describe the molecules by combining their letters and the numbers. And that thing is called the chemical formula. The chemical formula of that molecule. What is the chemical formula? It is the combination of symbols of the elements and the numbers of the elements. How this we will discuss. The letters tell which type of atoms are in the molecule. The letters in the molecule, A, B, C, whatever, those symbols will describe which type of element is there, and the subscripts, the numbers, they indicate the number of each atom, and the subscripts, they will tell how many atoms are there. Like for example, the oxygen we breathe is a molecule formed by two oxygen atoms, and its chemical formula is O2. If its chemical formula is O2, so it means, what is the symbol? What is the letter? O. O means only oxygen. So it means in this molecule only oxygen is there. How many atoms of oxygen? It's written 2. So it means 2 atoms of oxygen. This is a molecule of oxygen. So how much it would be? It's only O, so it means there is only oxygen. How much? 2. It means 2 atoms of oxygen is there in this molecule. Okay. Now, on the next page, we have how are elements grouped. Each element has a symbol. as we have discussed before, of the oxygen. Oxygen has oxygen, the symbol of oxygen is O. The symbols for most elements are one or two letters. It means for some symbols there is only one letter. For some letters, for some elements there are two letters. For example, hydrogen, there is only one letter, H. For helium, we use He, two letters. So for some elements we use one letter. For other elements we use two letters. The first letter is always capital. Second letters are always small or are never capitals. Means the first letter will always be capital and the second letter will always be a small letter. Now in the second column we have symbols may look like an element's English name, like C for carbon. How we will name it? We will take the first letter of its English name. We will take the first letter of the English name, like carbon. So we take C, C for carbon. However, many come from ancient names such as Au for gold, whose Latin name is aurum. Sometimes we use English names, sometimes we use Latin names for some elements, like gold. We don't use G for gold. The Latin name for gold is aurum, A-U-R-U-M. So we use AU for gold. We are using two letters now. So A will be capital, U will be small. Okay. The element symbols are the same letters used in chemical formulas. Now, wherever we need to use the symbol, we will use these symbols. These are fixed. Like C is fixed for carbon. Wherever we use to write carbon, wherever we need to write the symbol of carbon, we will use C. Either it is chemical name, it is a chemical formula, or we are writing chemical reaction, whatever. We are writing chemical equation, whatever. Whenever we need to write the symbol, the symbols are fixed now. So we will always use these symbols. C for carbon, Au for gold, H for hydrogen, He for helium, and so many. At the bottom of the page, you have a section of the periodic table. Now, what is periodic table? This we will discuss on the next page. Like, you have this one. What are all these things? Like, for example, if we take H, the first one we take. So what does it mean? The name of the element is written, hydrogen. Its symbol is written, capital H, and its atomic number is written, 1. Atomic number, we have discussed yesterday, atomic number is the number of protons in an atom. So what is hydrogen? It is reactive, it burns readily, it burns very quickly, it is gas at room temperature, and it is a non-metal. Then we have potassium, K. We are not using P, it means we are using its Latin name. Potassium is symbolized as K, capital K, and its atomic number is 19. Atomic number 19 means number of protons, 19. It is very reactive. It starts fire in water. It is solid at room temperature, and it is a metal. Then we have carbon. Its symbol, capital C. Atomic number 6. It is very reactive. It can burn. It is solid at room temperature, and it's a non-metal. Then we have Fe. Fe is iron. Again, we are not using I, we are using Fe. It means we are using the Latin name. Fe, capital F is small e. Its atomic number 26. It is reactive, rusts quickly. Rust we have done before. It rusts quickly. It is solid at room temperature, and it's a metal. We move on to the next page. In the next page, we have a little description about the periodic table. In 1869, there was a scientist, Dmitry Mendeleev. He made element cards. He ordered the elements from lightest to heaviest. He arranged all the elements from lightest to heaviest. He found out that the elements' properties repeat in cycles. When he arranged all the elements from lightest to heaviest, he found out that the elements properties, they are repeating in cycles. They are repeating continuously. He made the cycles of elements into rows in a table. Then he made rows and columns in the periodic table. What are these? Just wait, I'll tell you. Mendeleev's table is called a periodic table. Means the periodic table which is shown below. This is all the periodic table. This is the periodic table. Okay. Here we have rows and columns. What are these? I'll just wait. Mendeleev's table is called a periodic table because the properties repeat in cycles or periods. Now, what are cycles? What are periods? I'll just explain you after finishing this one. Each column contains elements with similar chemical properties. The columns which are there in the periodic table, all the elements in one column, they have the same properties. For example, elements in column 17 combine easily with other elements. The elements in column 18 do not react with other elements. Means if you talk about column 17, all the elements in column 17 will have the same properties. They react with other elements. But if you talk about column 18, they do not react with other elements. So if they are in separate columns, column 17, column 18, it means their chemical properties don't match. Their chemical properties are not same. Now we come back to the periodic table. Now half of the periodic table is on 494 and half of the periodic table is on 495. If you move from up to down vertically, like this one, so this is called a column. This is called a column. The other name for column is group. The other name for column is group. So we can say like the numbers are written. 1, it means group 1. Here it is written 2. So this is group 2. This is group 3, group 4, group 5, group 6, group 7, and so on. So all these are called groups. Okay. If you move from up to down vertically, so this is one group, this is second group, third group, fourth groups, and so on. All the groups, all the elements in one group, they have the same properties. Like for example, if you talk about group 17, F, fluorine, chlorine, bromine, iodine, these all elements will have similar properties. Okay, this is column or group. The other thing, if you move from left to right, K, Ca, Cs, Ti, if you move horizontally, this is called rows. These are called rows or period. So this is one row, first, second, third, fourth, fifth, sixth, seventh. These are called rows or periods. Okay. Now there is a key. What is this? We are using some colors also. This I have told you. The first one is the element name, element symbol, and the atomic number. This blue color is representing metal here. The green one is representing metalloid here, and the yellow one is representing non-metals. And this one, blue with a red border, this is artificial element. Okay, so I stop it over here. From the next page, inshallah, we will continue tomorrow. That's all for today. Thank you so much.